All right, today we're jumping headfirst into a really fascinating speculative paper. It proposes something pretty wild, a deep, hidden connection between some of math's most famous numbers. We're talking about a cosmic resonance, the idea that these constants aren't just random, but are actually humming in harmony, in a way that could change how we see the very blueprint of the universe. So let's just get right to the big question. Are pi, e, and the golden ratio, the numbers that define circles, natural growth, and even beauty, are they secretly connected? I mean, are they just individual superstars in the world of math, or are they part of some hidden family working together behind the scenes? So to dig into this, the paper gives us, well, this thing. It's called the golden angle Euler resonance invariant. Now, don't get hung up on the formula itself. Seriously, don't try to memorize it. What's really important here are the ingredients. You can see them right in there. We've got pi, we've got the golden ratio phi. They're all baked into this one single equation. And that is the key to this whole puzzle. Okay, but this is where it gets genuinely mind-bending. When you actually plug in the numbers and calculate the value of this new formula, you get about 1.649. Now, what's so wild about that? Well, that number is unbelievably close to two other really famous values in math, the square root of e and pi squared divided by 6, which is the answer to a classic problem called the Basel problem. Look at those bars. They're almost identical. So the question is this just a 1 in a billion coincidence? Or is something much, much deeper going on here? All right, so how are we going to unpack this? Here's the roadmap. First, we're going to explore the strange, theoretical universe where this idea was born, the theory of infinity. Then we'll look at a simple clue, build a little theoretical machine, and finally, we'll see exactly why this resonance probably isn't a coincidence at all.
So first up, the theory of infinity. See, to really get why these numbers might be intertwined, we first have to understand the framework this paper is built on. And trust me, it's a very different way of thinking about math itself.
In this theory, infinity isn't just some abstract concept. It's more like a physical thing, a massive, churning ocean of pure potential, or chaos. The paper calls it a plenum. And the only way to get anything stable or orderly out of this chaos, like a shape or a number, is by applying a rule of symmetry. Symmetry acts like a filter that calms the storm and lets a clear, stable pattern emerge from the noise. And the theory says this happens in a three-step recipe. First, you have psi. That's the raw, unbounded chaos. Then comes phi, which is the principle of form. It's like a template that gives that chaos some structure, and it often uses the golden ratio to do it. And finally, you have theta, which is closure. Think of it like tying off a balloon. It takes that newly formed structure and seals it, making it a stable, finite thing. So you go from chaos to form to a finished system. Okay, let's make this less abstract. We're going to look at a brilliant little example that shows this principle of symmetry in action. This is our first real clue.
So take a look at this formula. It's called the Konrad triple invariant. And yeah, it looks like a total mess, right? It's complicated. You throw 3 numbers in and it spits out some answer. This represents our starting point, our little pocket of mathematical chaos. But watch what happens when we apply one simple rule, a symmetry constraint. In this case, it's the Fibonacci rule, where A is just B plus C. The moment you apply that rule, all of that complexity, all those cubes and fractions, they just magically cancel each other out. And that messy formula collapses into this beautifully simple expression, 2B plus 3C. It goes from a chaotic mess to a clean, simple line. And that, right there, is the core idea of this entire theory in a nutshell. By applying a simple rule, asymmetry, we didn't actually change the formula. We just revealed the hidden order that was buried inside it all along. It's like we found the secret password that suddenly makes everything make sense. Okay, so if symmetry can reveal order, what if you could build a machine that uses this principle to actively create order from chaos? Well, that is the whole idea behind something the paper calls the Amanda engine. You can think of the Amanda engine as a little factory for creating orderly systems. It starts with that Fibonacci backbone, that simple rule we just saw. Then it starts injecting chaotic little impulses onto a circle. But it does so using the golden angle, which is the most symmetrical, orderly way you can possibly do that. Then it calculates the overall pattern that emerges. And finally, it's constantly checking its own work to make sure everything stays balanced and stable, essentially tying it off into a perfect little bubble of order. And this brings us right back to our original mystery,
Because once you understand this theoretical machine, you can finally see why that weird resonance we saw at the beginning isn't a coincidence. It's actually an expected result. So that crazy formula from the start, it's not random at all. It's basically the blueprint for the Amanda engine. The 2 pi on the formula, that's because the engine is working on a circle. The golden ratio, phi, that's the rule it uses for perfect symmetrical placement. That pi squared over 6 part, that's the math that just naturally appears when you close the loop and make the system stable. And E, the number of growth, that just pops out of the complex dynamic way the whole system works. Every single piece of that formula has a job to do. So what this invariant is really doing is acting as a bridge. On one side, you have the discrete step-by-step rules of the engine itself, its Fibonacci logic, its golden ratio placement. And on the other side, you have the continuous universal backdrop of mathematics, which is governed by constants like pi and e. The invariant is the exact point where the machine's internal rules lock in perfectly with the universal laws of the cosmos it lives in. So what's the big picture? What's the profound takeaway from this whole mind-bending journey? Well, the big idea here is that this resonance invariant, and others like it, they act as anchors. They are these special formulas that allow a finite computational system, like our little Amanda engine, to stay perfectly in tune with the infinite universal harmonies of the mathematical reality it exists in. In other words, these formulas are like a tuning fork. They allow a small, finite machine to resonate perfectly with the infinite universe of math that surrounds it. They're not just a coincidence. They're the secret handshake that proves a small, orderly system is perfectly in sync with the boundless cosmos. And that just leaves us with one last thought to chew on. If mathematics really is the blueprint for our reality, and we're just now discovering these incredibly deep resonances between its most fundamental building blocks, well, it just makes you wonder, doesn't it? What other cosmic harmonies, what other hidden connections are just sitting there waiting to be found?